4.2. And these are all just different shapes outlined for you. And in each of these, perhaps you see it, perhaps you don't. What are you looking for in all of these pictures? Theoretically, there should be some parabolas in all. And I wouldn't say that that's true. And I can't say for sure what's parabolic and what's not. I can say for sure that the path of the water, parabolic. Okay? Path of the water is parabolic. I can't say for sure on any of the others. I feel for sure this is not a parabola. Why not? Why is this one right here not a parabola? Well, I think that it's really referring to just this piece right here in the picture. I could be wrong about that, but I think this is what it's referring to in terms of what the parabola is.
I think it's just because the real surface of the moon is really bumpy, so it's not like a perfect straight parabola.
Let's say that they went up there and they brought some equipment and they smoothed out the moon. Would it be a parabola then?
No.
Again, why not?
It's 3D, it's a sphere.
Okay, but this isn't 3D. Let's see what else.
It's a circle.
Yeah, it's a circle. It's not a parabola. Cutting off a circle right here does not give you a parabola. It gives you an arc of a circle, not parabolic. I don't know what this is, but it looks like a launched object, and I would say that's a parabola. I don't know about, this is, where is this?
Missouri.
I heard Missouri. Is that where it is? St. Louis. Okay, so St. Louis, Missouri. I don't know if it's a parabolic arc or not. I'm sure you could find that out. I do know that parabolas occur in nature, and they also occur in things man-made as well. I'm going to give you a couple of examples real quick of parabolas man-made. And I might have one to show you here. See that? What is it? Flashlight. Right? If you slice the flashlight anywhere, the reflective material is parabolic. Where else do you see this? Where else do you see that shape?
Some rocket nose films.
That I couldn't say for sure.
Some of them.
Again, I couldn't say that they are or are not parabolic. But where do you, every single one of you have seen these?
Radio dish.
A radio dish? I don't know what that is.
Satellite set.
Oh, the satellite dish on your house? Absolutely parabolic. Right? What else? Bowls. Depends on the bowl, I would guess. I don't know if any one particular bowl would be considered parabolic. It could be, but I don't know. But if you go out in the parking lot, I guarantee most of the car's headlights are parabolic. And there's a reason. You'll see the reason in a little while. Other things. I'll give you another example. Some of you have been to the science museums when you were kids, or even when you're grown into who you are now. There's some place in the science museum, they have a couple of chairs, and they're on like way opposite sides of the room. And you sit in one chair, your friend sits in the other chair, and you can have a, yeah.
The movie theater and any theater / stage has an arc, so that way everyone gets it's pointed towards the center of the stage.
Again, I I don't know, but that's possible, but an arc is not the same as a parabola. So I don't know that they are set up on a parabolic curve, but the two chairs have parabolic collectors behind you so that when your friend talks, their sound is collected and you're in the perfect spot to hear, and again, you'll see why in a minute. The Western States Trail, I think you can pick it up at the lake, and you can take it all the way up to Squaw. Okay? On the Western States Trail, past the lake, when the lake turns into the river as you're heading up towards Auburn, you go in and out of these little ravines, but you stay at the same level. And there are certain ones of those that are pretty significant in distance. And if you get to a certain point, there can be people a half a mile away talking, and you can hear them like they're right next to you. Because you have a parabolic cutout, and that's my theory that it's parabolic. And you end up in the perfect spot for that. And we're going to talk about why all of those things work. And we're going to relate what we know to where we're headed in terms of these equations. So this particular equation could be written or recognized in standard form. It could be written or recognized in transformational form. But regardless of how you're looking at it, you want to be able to recognize the parent graph is y equals x squared. The translation vector is what? 0, 0. And the vertical stretch factor is 1, 4. And you guys are getting to the point where you're really good at these graphs, starting at the origin. Normally we would go right one, up one. What are we going to do? Yeah, we just get a little bit of a rise on both of these sides. And then right 2, up 4, right 2, up 1. You could do right 3, and you'd go up 2 1/4, right? And if you wanted to do one more just for fun, right 4, you would go up 4, 4. And sometimes you're going to need to go out further than normal, 1 or 2 spaces. And then when you connect, that's your picture. And I think you guys are getting to the point where you're pretty good at doing these graphs. Then we talked about last week standard form. When your b value is odd and a doesn't work where it's going to cancel out with the b, you end up with fractional translation vectors, and that makes it pretty difficult to graph. Our list, y equals x squared. The vertical stretch factor for this one is what? Negative 1. And the translation vector is going to be a negative 5 over 2, comma. How are we going to find out what the y coordinate is?
Hold on. No, that shouldn't be negative. Not negative 5 over 2, it's 5 over 2.
Okay. How are we going to find out what the y coordinate of the translation vector is? Plug it into your equation. So you're going to have y equals the opposite, 5 over 2 squared, plus 5 times 5 over 2, minus 2. So you're going to end up with a negative 25 over 4, plus 25 over 2, minus 2. So the numbers are not, they're just not conducive to nice, simple graphs. So negative 25 over 4 plus 50 over 4 minus 8 over 4. So you're going to end up with, looks like 17. Oh, yep. Should be 17 over 4. You can check me on that, but you know most of you are just sitting there like this, watching somebody do it. That's the difference. So So it's 5 over 2, 17 over 4. You're at 2 1/2, 4 1/4. It's not a very pretty point. And instead of a horseshoe up, we're going to go horseshoe down. And it's only a vertical stretch of -1, so it's not too bad to graph this. Right 1, down 1. Left 1, down 1. Right 2, 1, 2, 3, down 4. And left 2, down 4. If you wanted to go right 3, you could go down 9. And here, left 3, down 9, somewhere in there. Did I make a mistake? Did somebody see something? Any questions on standard form, graphing from standard form? Okay. What's this 5 do to your graph? Moves everybody up 5 units. What does the -3 do to your graph?
Moves the vertical stretch down and makes the parabolic.
So it turns it over.
Yeah, turns it over.
And what else does the 3 do? Stretches it longer and skinnier. So we know that we're going to start at 0, 5, and we're going to be 3 times taller, but we're going down instead of up. So right 2 up 4 becomes right 2 down 12.
Which is that it makes it 10.
And so when we draw our graph, the idea is okay. So the idea is, can you get the parent graph flipped and moved up at the same time? Can you make the list and recognize from standard form what's going to happen to your graph? Translation vector ends up being 0, 5, and vertical stretch factor -3. The more of these you do, the better you get at them. The more you watch, nothing's going to change for you. You've got to make it happen. Now, this one, I want you to graph, because this is the first one that's going to give you insight to where we're headed today. So take a second and see if you can get this one graphed. So again, you want to make the list. You can recognize you're in standard form. You should be able to recognize your parent graph is y equals x squared. You should have been able to come up with a translation vector and instantly come up with the vertical stretch factor. What's the vertical stretch? That's the easy one.
-1.
That's easy. What's the x coordinate of your translation vector?
-3.
You should have had a -3. Okay? Is anyone not getting -3 and want to see that worked out? If you need to see it, let's do it. So the x coordinate of our vertex is the opposite of b over 2a. So b is -6 and a is -1. How many negatives are in there? 3. So that means our answer is negative. So you're going to have a negative, and then 6 divided by 2 is -3. Okay? That's one of the easy ones to screw up, especially when you're doing stuff in your head. It's easy to make that mistake. So -3, and when you plug in -3, what are you going to get for y? +9. Everyone okay with that? 27? So let's take a look. You have -x squared, y equals -x squared minus 6x, right? Remember, you got to use parentheses for every x. And we're putting in -3. squared a positive 9, and you got a positive 3 to get positive 9, we want to be the opposite of 9. And then we're going to be plus 18, right? Instead of a positive 9 plus 18, which would have gotten you what you wanted. But that's a very easy mistake to make. Once you have negative 3, 9, here you are. Write 1 down 1, write 2 down 4, and write 3 down how many?
Down 9.
Down 9. So there's your graph. There are 3 points that I consider to be most important on parabolic graphs. Now, we've done everything in isolation, very little application. But the things that become important, which points are important? The vertex is typically important. What else? Somebody else. What other points in a parabola are important? The x-intercepts would be what I would consider the other 2 most important points, and in some cases they're more important than the vertex. Depends on the question. The x-intercepts are at 0, 0, and negative 6, 0. From this equation, okay, how else could I find the x-intercepts? What do you know about all x-intercepts? What's true about all x-intercepts? So if I have an equation and I want to find the x-intercepts, plug in a y of 0 and solve. And how did you learn to solve these? What's your favorite F word? Factor. That's how you want to do it first. And what could you factor here? Negative x. And what would be left? Plus 6. What value of x makes this 0? 0. And what makes the other factor 0? Negative 6. So your roots are 0, 0, and negative 6, 0. The same thing we got on this graph. Negative 6, 0, and 0, 0. The x-intercepts are going to be really important to us. So far, we've glossed over them unless they were integral. We haven't really talked much about that. We also know that all of these have an axis of symmetry. They all have a vertex. They all have the axis of symmetry. They all, almost all, have x-intercepts. And you need to be able to find them. One way is graphing. The other way is factoring. Excuse me, and we have other ways as well. We talked about transformational form. We've done transformational form with x squared, x cubed, square root of x, cube root of x, and what was the other one? Absolute value of x. Your vertex is CD. Your translation vector, also CD. This is an ordered pair with parentheses. This is a translation vector with vector notation. The vertical stretch factor is A. Axis of symmetry has an equation of x equals c. And we know that when A is less than 0, we're upside down parabola like a rainbow. And when A is greater than 0, we're right side up like a smile. This is nothing new for you guys. Okay? Graphing these is incredibly fast. Where's the vertex?
Negative 5.
So if we're going to be at 3, instead of right one up one, we're going to go right one up a half. And right two up two, and left and right three up 4.5. Right? And when we look at the graph, what do you know about these x-intercepts? So what aren't they? They're not integers. They might be rational, but not likely, and they just don't appear to be integers. Right? Where's the vertex? -1, -2. So when we're making our list, again, transformational form is the easiest. The translation vector, -1, -2. The vertical stretch factor, again, is 2. Is anyone not seeing where those things are coming from? Is anyone not 100% clear on this? Translation vector, vertical stretch factor, parent graph.
Is there a way you can turn standard form into transformational form?
There is.
It just takes a while.
Just something, why would you want to? It's faster to do when you're in that form, but we know how to graph from standard form.
No, I'm just wondering.
Yep, there's a way. So, translation vector, -1, -2, and then right 1 up 2, left 1 up 2. Right 2 up 8. And left 2 up 8. So this is going to be twice as tall. Transformational form, we want you to feel pretty comfortable with that. We want you to be able to look at it and say, we're at 4, 1, right 1 down 1, right 2 down 4, right 3 down 9. I don't want this to be a mystery for you at all. And I still am not 100% sure that everyone's got this. I still think people are looking at this and they're not 100% clear on how to get this picture from that equation. Even from the list, parent graph, y equals x squared, translation vector of 4, 1, and the vertical stretch is -1. I'm still not sure everybody's got this down. Right? And if you're one of the people that are struggling with this, please come in and get yourself dialed up on that. Now I'm going to show you a couple things here. I'm going to skip some things in here, but there's a couple in here that are pretty good for you to see in terms of what this is doing for us. Okay, so in here, this is parabolic form. It's can also be in standard form. This is parabolic or transformational form. Things, they talk about the satellite dish, a searchlight or a flashlight. Every parabola has a point called the focus, which in these pictures is located at this red dot. We do not teach right now what a focus is. A parabola is actually made up of points that are equidistant from a focus and a directrix. And when we do conics later in the course, that's when we're going to get into this. That's how a parabola is generated, and we have an equation that writes it. But we don't include focus, and we don't include the directrix. Here's the focus. And literally, what it does is it focuses, this point is what the whole dish will focus all the radio waves, or if it's a satellite dish, the waves that are sending you the information about the television program you're watching. In this case, it disperses light, but it focuses the pattern of light when you use a searchlight or a flashlight or something like that. Now, I think most of you have probably had the experience where you had a flashlight, and we have some at home where you can change where the light bulb is, and it makes the beam either a bright wide beam, it's not as bright, or you can focus that beam into a much more focused direct where you have a smaller area that you can see. And it matters where that light bulb is. I think let me go back. If waves come into here, so you can see there, that's what I was hoping for. So in this one, it's collecting waves. If wherever it comes in, they all bounce and they end up hitting the focus. Here, the light is emitted in all directions, and anywhere it comes out, anywhere the light comes out, it's sent straight out of the parabola. Okay, even if the light that comes back here goes back out straight, everything goes out, so it comes out of the bulb straight.
What if the stuff hits it at a different angle?
Which stuff?
Well, like the incoming rays?
Like these things here?
Yeah, like
Remember,
if it
there's
came in,
only one source for that. It's not multiple sources for your satellite, is my understanding, right? So your dish is pointed at a satellite that goes around the Earth, so it just stays pointing. And that satellite is emitting waves that cover a certain area of the Earth or the United States or whatever. This guy is pointed and will only get what's coming out of that satellite dish is basically the ones that are going to fit straight in there. So it's, you know, when you look at the Earth and the satellite's here, and it's sending these rays down like this, the only ones that are going to get in your little itty bitty collector are going to be ones that are right next to each other, so they're going to be almost coming in parallel to each other, almost. But there's not another satellite, like you were saying, if we had another one over here collecting, it would not work. Not work like that at all, because like you said, it'd be bouncing all over the inside. It has to be coming straight into that.
is there a way to collect like stuff coming from every angle and send it to one first one?
What kind of stuff?
Well, like, I mean, just waves.
Waves from?
So, hitting.
Well, again, the source, right, whether it be the satellite up here, whether it's the sun, there are solar collectors that are parabolic, and then they focus all the sun's rays into that focus point. Same thing. It's coming from one source, even though it doesn't feel like it, and that sun is obviously huge. You only have that one little slice. So the rays come in, bounce off the collector, and are focused on that focus point. So there's not two suns, that idea. So you're not pointing at the sun, but then getting rays from another sun, if that makes sense. And if you put in here, if you put two light bulbs, it doesn't work. The only one that would really help you is the one that's out of focus. And just like this, if your satellite's here and your dish gets moved, like the raccoon climbs up and moves your dish, so that you're getting the rays from the satellite but not directed towards the dish, what happens to your picture? Yeah, that's going to be a mess. Because all the rays would be coming in like this and bouncing all over the place. And I don't know if we can, I think there's one, well, I'm really not dialed in on this. So if we change the angle, yeah, cool. So it doesn't go to the focus. Okay. And this is going to take all day to get. So I hit the focus. I don't know if we're waiting for it to focus.
It's like that Windows thing where it just keeps bouncing.
Okay, so are we going to get another one? We get another one. Oh, really? Okay. Oh, it didn't go down straight, huh? Another shot of it. anything that comes straight down, it doesn't matter where I put it, it's going to go straight through. Okay. So you can see there's just some different things. If you're in standard form, which one moves you up and down? Which coefficient in standard form? And they're calling our standard form is their parabolic form. So they want to know about A's, H's, and K's. Who moves you up and down? The letter A or choice A?
Letter A. No.
Yes. Okay, so this one, are we stretching or compressing the parabola? Which coefficient do you have to change? And again, we're in standard form. This is standard form. Parabolic form is what they're referring to. Which one do we change in this, right here?
Letter B.
Yeah, so which, in where I'm pointing, we want variable A to change, and that's what stretches or compresses. Still in this form right here, which moves the parabola to the left? H, so what letter? C? Which coefficient has to be negative in this form to make the parabola go down? Variable is A, so letter A. Now we're in general form, which is our standard form, and I don't want to confuse you with that. This is this website's. The honors class calls this general form. Okay? So in order to move up and down, who do you move? Which variable? Right here. Which one? C. That would be choice A. Who has to be negative? A. So it has to have focus point, and then rays entering vertically will always reflect to the focus point and then leave the parabola vertically. So it does both of those. Okay? What do these look like here? What does this form look like? What do these things look like? They look like that. And there are some books that will call this factored form. Some call it intercept form. Our book calls it intercept form. What is A? Vertical stretch factor. A is vertical stretch factor all the time. All of our forms. If you're in factored form, x minus p, x minus q, p0 and q0 are your roots. They are your x-intercepts. How do you figure out what p and q are? Take the opposite of what's with x. P and q are the opposite of what's with x. Your vertical stretch factor is still A. And I'm going to go back here a second. I'll come back to that. Where's that one? This is true anywhere on the graph. If you go horizontal and you slice your parabola horizontal, you're going to hit a couple of points usually. Those points are going to be the same distance away from the axis of symmetry. So the distance from the axis of symmetry to each of your x-intercepts is the same. That means the axis of symmetry is halfway between your two intercepts. So if I want to find out what the equation for the axis of symmetry is, take your p and q values, add them up, divide by 2. So this was at -6, this is at 0. Add them up, you get -6 divided by 2 is -3. That's the equation of the axis of symmetry. also the x-coordinate of your vertex. If I know the x-coordinate of your vertex, how do you find y?
Plug in.
Plug it in, which is what we did earlier. So when you're looking at standard form, intercept form, you can find your intercepts at P0 and Q0, add P and Q together and divide by 2, and that's the x-coordinate of your vertex. It's also the equation for your axis of symmetry.
So add that together and then divide by 2.
Once you know x, how do you find y? Plug it in. Just take whatever you get here, plug it in for x, and you'll solve for y. This form is not very common. It's more of a novelty, for lack of a better word. It's great that you can get the intercepts, but you still need to be able to find the vertex, the axis of symmetry, and everything else from here. Okay? Let's take a look. Sure. How are we doing? Good. Rachel. Rachel looks like Mandel. What do you got going today? Drill? You sick? Sure. Alright, so this is in factored form or intercept form. Your x-intercepts are what you're going to start with. What are the x-intercepts?
0, 4.
Nope. 0, 0, and 4, 0. I like to plot those first because sometimes the visual is helpful for me. When you add up the P and the Q, 0 and the 4, and divide by 2, the axis of symmetry is what I would find next. X equals 2. Which means my vertex is going to be 2, comma, and then how do I find out what y is? Plug the x back in. What kind of a y do you expect to get from this equation? Positive. Okay, so when you plug in a 2 for x, what does y end up being? So my vertex is at 2, comma 4. What's your vertical stretch factor? -1. You can use that to verify that your graph is going to be correct. Yes?
Put it like P plus 2 over 2. So you put 4 over 2.
4 plus 0 divided by 2. Right? It's not -4. P is what's opposite of what's with the x. And in this case, it's x minus 0. So that's going to just... But don't get fooled by that negative. So from here, right 1, down 1. And you can see that when we go right 2, down 4, we hit our points that are the x-intercepts, which is what we want to have happen. The 2, I didn't show it, I probably should have. The 2 is for finding the axis of symmetry. The x-coordinate of your vertex, or the x value for your axis of symmetry, is P plus Q over 2. So 0 plus 4 divided by 2 would be 4 over 2 or 2. Okay? Sometimes it doesn't work so pretty, obviously. First one I'm showing you, I'm not going to give you an ugly one. Sometimes you end up with a fraction, 9 over 2, whatever. It's just the way it goes. Want to get the scissors? We got a split end problem there or what? Maybe a hot oil treatment would do some... But, I mean, I have that problem all the time with the split with ends? So we know our parent graph is still y equals x squared if you were to multiply that out. It's easy to see the vertical stretch again. That just never changes no matter what form we're in. What are we looking at? 2. But now we go to x-intercepts. What are the x-intercepts going to be? 1, 0, 2, 5, 0. That means the axis of symmetry is going to be x equals 3. And the vertex will be 3, comma, b. The x-intercepts, look at your x. What's with the first x? Take the opposite. That's p. What's with the x? Take the opposite. That's q. So we're going back to this form again. And we want to get used to that. Anytime you're dealing with x parentheses, in a binomial like that, you take the opposite to get the value that you're looking for. P is what you're subtracting. You don't want to get caught up in what I'm subtracting. You want to just say, hey, just take the opposite. My life will be way easier like that. Okay? So that gave me 1, 0, 5, 0. Add those two together and divide by 2. And then plug the 3 in for x. Get negative. Did I go too fast? Everybody's going to be different. What did you get? Once you know what x is, plug it in. Y equals 2, 3 minus 1, and minus 5. What's 3 minus 1? It is. And what's 3 minus 5? Negative 2. When you multiply 2, 2, 2, you get 8, and 1 negative, negative 8. Okay? Now, some of you are going to do it in your head, and you're going to get it wrong. Write it out.
Wait, so are you just doing the axis of symmetry in your head right now?
One more time?
Are you just doing the axis of symmetry in your head right now?
I did.
Okay.
And if you want, we can write it down. The x-coordinate of your vertex is going to be 1 plus 5 divided by 2.
Okay. Do you keep the opposites of what are in there?
Take what's here and here.
Oh, okay. Oh,
Get those, that's P and Q, just
right.
like we just said, just 3 minutes ago.
Right.
What's with the x?
Negative 1. So you
Take the
1.
opposite.
Yeah.
That's
okay.
P. What's with the x? Negative 5. Take the opposite. That's Q.
All right, that makes sense.
Look on your notes. P plus Q over 2, that's
right.
the x-coordinate for your axis of symmetry.
Right. I just wasn't sure if you're doing
No, that's good. Keep asking those questions. Don't, if you're not clear on, especially with the plus minus stuff, holy crap. That's the end all. Once you screw up the sign, everything you do after is like these dominoes. You push a domino, and if you push the wrong one, you can do all kinds of good things, but because this was bad, your whole picture is going to be bad.
Right.
All right, so we want you to be crystal clear on that. We know that 1, 0, and 5, 0, we should be crossing the x-axis here. From the vertex, how do we get to our first point? Right 1, up 2. Right 2, up 8. Some of you are only doing vertical stretching on the first one, right 1 and left 1. And then you just abandon. So I watched people on that last test, they'd go right 1, up 2, but then they went right back to the parent graph, right 2, up 4. They put a point right there. Not. It's all the ups get multiplied by the vertical stretch factor. So when we do actually hit that graph, we expect it to look like that. Right? So this is intercept form. This is intercept form. We still are looking at a parabola, but this time you're going to have x-intercepts of 0 and
-1.
yeah, -1, 0. So this is going to make for an ugly axis of symmetry. Axis of symmetry. Where will that be? 1.5 or 3/2. I would encourage you to stay with improper fractions. It's just good in the long run for you to be able to work with those. So that means my vertex, and notice when I'm writing a vertex and not a translation vector, I'm using ordered pairs. So it has to be 3/2, comma, something. Right? 3/2, comma, something. Let's see if you can find out what a comma something is. That sounds good. So 25/2. Feels like it should be negative. All right. Is anyone not sure how to find the y-coordinate of the vertex? Plug in the 3/2 for x, right? So we're going to have 2 times 3/2 minus 4 times 3/2 plus 1. That's going to be 2. This would be -5/2. And this is going to be +5/2. So your answer has to be a negative. So when we multiply, you're going to have 2 times a -25/4. When we cross cancel here, you're going to get -25/2. Now, more than half of the people in the room didn't do that. They waited and let somebody else do it. Those people typically struggle mightily with fractions. And if you're one of the people who struggle with fractions, I can't encourage you enough to do these problems. They're easy, they're controlled, and it's instant feedback if you do them in class. Yeah, I know how to add and subtract fractions. So this is not going to be pretty. 1.5, what was it, -12.5, way down here. But your x-intercepts are pretty. 4, 0, and -1, 0. So from here, it's right 1, up how many? Up 2. Left 1, up 2. Right 2, up 8. Right up here, and left 2, up 8. And you can see that when you connect your graph here, or when I connect the graph, that actually we luck out, even though they're not pretty points to generate the parabola, our x-intercepts are nice. And that's the best thing about intercept form. You can get the intercepts very quickly, very easily. Whether they're pretty or not is irrelevant. Y-intercept's always easy. Standard form's the easiest because it's always 0C. But if you're in parabolic or in intercept form, if you want the y-intercept, what do? Well, you can't cover up that whole term. What do you mean by cover them up? Make them be 0. So 0 minus 4, 0 plus 1, -4, and a positive 1. So if we just look at that and just say, okay, it's a product, 2 times -4 times 1, if that's what you meant by cover up, I think that's good. So you're going to end up with a -8. And that's right what we got right here.
And then could you use like axis of symmetry, like have a -8 on the other side to get 2 points?
Well, again, if you already have done your work and you know these two, add these up, divide by 2. That is the axis of symmetry. There's not a lot of work to do in that. And you need that for the vertex anyway, because you know that the axis of symmetry is always going to go right through the vertex. So once you know what every x on the axis of symmetry is, you know the x of the vertex. Then we plug that in, that's how we get the y of the vertex. practice, the better you get at it. The two words that I get afraid of that most people would say, isn't that what you want from your students? I'm afraid when students say, I understand. Of course you understand. I've been doing this for a long time. I don't want you to say, I understand. I want you to say, no, that means I've not done my job. I want you to understand, but that's not my ultimate goal. I can do it. I can do it by myself. I'm a big kid now, right? Right out of the commercial. Okay, I can do this on my own. Okay. Now, if you're going to be asked to do this, if you have intercept form and they want you to put it in standard form, you just need to multiply everything out. Now, there's a temptation to distribute this 3 first. Please don't succumb. Multiply your binomials first, then distribute, in this case, the 3, in this case, the -2. Let me show you this one, and then you can try the other one. So we are still going to be with the 3 here. But we're going to FOIL, or monkey method, or whatever it is that you do here. You're going to get, in parentheses, x squared plus 2x minus 24. And you should be pretty proficient, and I think most of you are. Now distribute the 3. So that's this equation that's in intercept form translated into a standard form or general form. The graphs are the same, the equations are the same. There's no difference. Okay? Anyone not seeing that? If you can't help yourself and you want to distribute and make this 3x minus 12 and then FOIL it, that'll work. Just don't distribute to both binomials, only one of them. But it's easier to do the binomials first. See if you can do the other one. See if you can do the B one right here. You've got to be careful. So my feeling is leave the constant alone and then multiply the binomials. X squared minus 3x minus 10. Then distribute, and don't forget this is a -2 that you're distributing. Y equals -2x squared plus 6x and plus 20. Now you're in standard form or general form. Any questions? Now, the other form that we know, transformational form or vertex form or parabolic form, how do we get that to standard form? This is predicated on you, from the very first week, learning what a perfect square trinomial is and being able to square binomials. And as I told you, 50% of you or more have no idea what those things are. And you are ignoring me now. You're not going to go home and learn them tonight, and you're going to suffer as a result. You've got to go to the factoring review, the very first file available in chapter 1. You need to be able to square a binomial. And you should be able to do it in your head, every single one of you, every single time. How do we do it? How do we square binomials? What do I call it?
Square the first 2 times, or double the 2. I don't know how to describe it in your way, but you do 8 times 2 times x, and then you can square the last.
Square the first, twice the product, square the last. That's the 9 words is what I use. I don't care if you have that, but I care that you can do it. Square the first. That's x squared. Multiply the 2 together in the binomial. Right here, that's 8x, and double it. That's 16x. And then square the last term. Plus 64. Plus 25. Now distribute the 1/2, the parentheses. Y equals 1/2 x squared plus 8x plus 32 plus 25. Don't distribute the 1/2 to the 25. Did I make a mistake?
-1/2.
It is -1/2. -1/2 x squared minus that standard form. See if you can do the other one into standard form. If you had a discrepancy, what kind of mistake was there? What kind of mistake, if you guys didn't have the same answers, what kind of mistakes were there? How do you describe them? Yeah, careless usually. Operator error.
Right.
So square the first, twice the product, square the last. Then distribute your negative 5. And then combine your like terms. And that would be your general form. Standard form to general, or parabolic form to standard form, or vertex form to standard form is pretty easy. Intercept form to standard form is pretty easy. Standard form back to either of those, well, certainly back to vertex form is a little more complicated. Going back to intercept form is a matter of being able to factor, but it's a little more challenging than just being able to factor. Only if they ask to, and right now you don't need to worry about it. Okay, we will want to be able to change standard form to parabolic form at some point, and we'll talk about that, but not today. The last one is, and I changed this problem, I didn't like the way it was worded, so I changed it a little bit because of how we deal with this function. An object is propelled upward from the Earth with an initial vertical velocity of 80 feet per second. So we are not, the angle at which this object is launched, whether it goes straight up or at an angle, doesn't matter. The vertical component is 80 feet per second. Its height after t seconds would be modeled by this function, h of t equals negative 16t times the quantity t minus 5. Where t is your time in seconds after the object is launched, and h of t, or h, is the object's height in feet. How many seconds after it's propelled will the object hit the ground? What do you know about the object when it hits the ground? What do you know about the object when it hits the ground? And what is it? Say it like you mean it. Zero. Height when the object's on the ground is 0 feet off the ground, right? Not trying to trick you on that. That's what you know when the object hits the ground. You always know the height. So if we want to know how long does it take till the object hits the ground, we're going to plug in 0 for the height. And in this case, we have this function. What are the values of t that makes that equation true? 0 and 5. What do those points or those values for t mean? Outstanding. Those are the x-intercepts. So in this particular case, we are expecting to have x-intercepts at 0 and 5. That means that somebody has this rocket launcher is flat out, or this ball launcher, or whatever you're shooting, water balloon launcher, they're leaving the ground at ground level. It's not a person throwing, because there's nothing out here above that we're adding to the initial height, for the initial height. So we would be able to figure out the vertex, and we can talk about that in a second. 0 and 5. Which of those is when the object hits the ground after it was launched? The 5. Because this is before it's launched. That's at time 0. Then the object's going to go up and come down, and it's going to take 5 seconds to do that. If you're doing applications problems in here, and I know some of you aren't listening to me right now, but I need you to understand this. Application problems are based in reality. Okay? If you throw an object, you can't have an answer of 2,549 seconds for it to hit the ground, unless you're a Thor. You can't throw something that stays in the air for 2,000 seconds. That doesn't make any sense. Equally ridiculous is to get a maximum height of 258,923 feet. That's like 30 miles. There's no unless or what ifs. You can't do it. It's not going to happen. So then the next question is, what is the object's maximum height? You have the calendar, right? 4.2 is homework. How do I find the maximum height? Okay, how do I find it? For this problem, how do I do it?
Add the y or x intercepts together and divide by 2.
So in this case, what am I going to add? So the x-coordinate of our vertex, or better, the t-coordinate of the vertex, is 0 plus 5 over 2. So that's going to be 5 over 2. How do I find out what the height will be when the time is 2.5? Plug in the 5 over 2 for t. So you're going to have h of t equals negative 16 times 5 over 2 and 5 over 2 minus 5. So negative 16 times negative 25 over 4 is going to be something, all right?
Yeah, you forgot. You didn't subtract the last multiplying them together. You subtract 10 over 2. About 5 over 2. No, you didn't.
No, I think we're good. So it looks like we're going to be at 100. So that means we would expect our vertex to be at 2.5, 100. So let's see if it's, so the maximum height of this object would be 100 feet above the ground. If you're getting things in the hundreds of thousands, even the thousands of feet, think about it. If somebody threw the object, there's no way. All right, it just doesn't make any sense to do that. Any questions on this one? 0, 5. I don't have 0, 5. These are 0 and 5 for t. So this is already in factored form. What do you know about the object when it hits the ground? Do you know the time it took, or do you know how high it is? Height, right? You have a quadratic equation equal to 0. It's already factored. Set each factor equal to 0. What makes this 0? What makes this 0? That's where the 0 and the 5 come in. What's y for those? 0. So the points are 0, 0, and 5, 0. Okay. Somebody else had a question too? Okay. So this is homework number 9. If you could start numbering those homeworks. Homework number 9. And this is the assignment for 4.2.